Welcome back. I hope you are doing great. As a part of this lecture, we'll understand more about the combiners. Let us take a different example here. So far, we have seen word count problem and also users view problem. Now, as a part of this lecture, we'll take a different example. Assume that temperatures are recorded on a daily basis for every hour in all the cities. As a part of our problem, we got to come out with what is the maximum temperature for each city on each day. That is what our requirement is. Maximum recorded temperature on a given day. That is what we need to come out with. How do we do that? If we have to apply the map and reduce logic, what will we do? What we will do is from each record, extract the date and the temperature. So all we need is date and the temperature. This will be the key. This will be the value, key value. At the reduce phase, find the maximum temperature for a particular date. If you recollect, both in word count and user view problem, at the reduce phase, what we have done is we have done a aggregation. For example, if we have twinkle some 1, 2, 3, all those times, we have added all these things and said twinkle is there 5 times. But in this case, our reduced logic could be different than this. Here, instead of addition, we are having a logic of max. I am trying to say the logic of the mapper and reducer differs from project to project. You got to be cognizant of that fact. I hope now the problem is clear. What we want to do is we want to find out maximum temperature in a given day. We can use mapper and we can use reducer. At the map phase, we can extract the date and temperature. At the reducer phase, we can find the maximum temperature. We know that our data is not at one place. It is distributed across 3 systems. This is one chunk, this is another chunk, this is the third chunk. As we know, mapper is assigned for each chunk of the data. In this case, we have 3 mappers because we have 3 data partitions. What is happening at the map phase? All it is doing is we from this table take the date, make it as a key, and from this column take the temperature, make it as a value. Very simple, right? All the mappers should be doing the same. Processing in this case is so simple. Mapper is just taking a one column and making it as a key, another column making it as a value. Nothing great about it. But at the reducer phase, if you see, it has to take all the key value pairs from mapper and it has to reduce and it has to find the maximum temperature in each day. If you can see, the maximum temperature on 12th December 2018 is 52, on 13th December 2018 is 55. Don't you think the map phase contribution is very minimal to get the final output, that is the maximum temperature for each day? Don't you think so? Yes, if you really see, that is what is happening here. Contribution from the map phase is very minimal. So is there any way can map phase or before reducer phase can we get more done? If you get back to our basics, What is the central theme of the big data? Distributed storage and distributed processing. More and more we are trying to process in a distributed manner. We'll try to get more things done in the less time. In this case, here very minimal is done here at a mapper phase. At the reducer phase, we are getting more things done. So we want to introduce something between mapper and reducer. In this phase, can we do something so that we are increasing the efficiency? We are trying to get more things done at the less time. What if we could implement a logic at map stage before reducer phase? Earlier, the question was, can we do something at the map phase or before the reducer phase? That was the question. Yes, the answer is yes. What if we can implement a logic at a map stage before the reducer phase itself? We can do that, right? We can definitely do that. That is where combiners come into picture. Combiner comes into picture between mapper and reducer. So now what is happening here is, after the mapper phase, we'll get a key value pair as a output. Now before this is sent to the reducer directly, combiner combines the values with the same key before they're copied over to the reducer. What does it mean? Let us take an example and observe that. Now, without having the combiner, ideally reducer would have got 6 results to reduce. But now, because we introduce the combiner, here in this case 3 combiners, what it is doing is, it is taking the output of a mapper and reducing it based on the key. In this case, we have 2 temperatures for the same key. Final result what we want is maximum temperature on a particular day. Wherever we have a same key, what it is doing is, it is searching for the maximum temperature between this and this. Whichever is the maximum temperature, that will be taken as a output. The same thing is done here as well. You can see on 13th December, we have 54 and 55 as the temperature. Out of this, 55 is the maximum. But why is that it is giving the 2 outputs in this case? That is because here keys are different. When the keys are different, there is a chance that this 48 may be the maximum temperature across this and this mapper. We are not sure. That is the reason what it does is, it takes the maximum temperature for a particular key within the same mapper, and that will be produced as the output. So now, because the combiners are introduced before the reducer, instead of 6, we are getting the 4 results to be combined. That is how combiners are working. Combiner works on the mapper output before it is sent to the reducer. It is as simple as that. One thing what we have to observe here is, in this case, the combiner has the same logic as that of a reducer. So reducer wants to find the maximum temperature out of a particular date. The same logic can be used by a combiner. Not much of a difference. Instead of having the combining of results at a reducer phase, all the results from a mapper phase would be combined by a combiner. Wonderful. We understood how combiner works. Now, what are the advantages of the combiners? It improves the parallelism. It reduces the data transfer. How does it do? How it improves the parallelism? What is happening here is, assuming that we have system 1, system 2, system 3. And after that, we are having a mapper. In system 1, we have mapper 1. In system 2, mapper 2, mapper 3. If you see, combiners are working in the systems where the data is there. They are taking the outputs of mapper directly and combining them in the same system before they are sent to the reducer. So more processing is done on the map node. So that way the capacity of the individual systems are utilized here, increasing the parallelism, increasing the distributed processing. Because combining of the results is happening at the system level itself before it is sent to the reducer, amount of data need to be transferred from system to the reducer would be reduced. If you observe in the earlier case, before the introduction of the combiner, we had 6 outputs for the mapper that need to be sent to the reducer. After the introduction of the combiner, instead of 6, we sent 4 output to the reducer. That way, amount of data to be transferred from the system where processing is done by the mapper, because combiner is combining the results in the each of the systems, the amount of data need to be sent to the reducer node will be reduced. We understood we can use the reducer logic directly as the combiner, but we got to be cautious. We'll see why in our next lecture. Thank you.